Alright guys, welcome to lesson 5 of unit 6. We're going to talk about integrating today. Use a lot of just old school strategies honestly to do a lot of the stuff we're doing today, but we're going to be integrating piecewise and absolute value functions. That's something that we haven't done yet, so this is a good time to toss it in there because it actually ends up making use of one of the properties we learned. Alright, so a piecewise function, in case you guys forgot, is a function that is comprised of two other functions, in this case 5 and 2x minus 1, that are connected at a common point 3. So I drew a picture here. Now you guys won't usually have a picture, just so you know. You'll just have the equation. But I drew a picture because, as you guys can see here, from 1 to 3 we have this function 5. It's just a flat horizontal line. But then after 3, at that connection point, the function changes into something else, a diagonal line, which is 2x minus 1. So for all x less than 3, we have one function, and for all x greater than or equal to 3, we have another function. Now, if I wanted you guys to actually find this integral, you would think, okay, well, let's find the area under the curve. We want to go from 1 to 5, and so you might think, okay, cool, I'm just going to go ahead and break that up into some shapes that I'm familiar with and just find the areas. Well, you could do that if I gave you the picture. But like I told you, you're actually not going to have the picture for these problems. The only reason I gave you the picture was to help you kind of understand the concept a little bit. So I'm actually going to erase the picture. This is what you'll typically be looking at for today's homework, okay? So how do we do this? Well, you have to understand that what we have is we've got two functions that are being connected at x equals 3. But I want to go from x equals 1 to x equals 5. So what we have to do when you're working with piecewise functions is you have to actually break your integral up into smaller pieces. So instead of going all the way from 1 to 5, I'm going to go from 1 to 3, that place where they connect. And then I'm going to go from, then I'll finish it and go from 3 to the last point. Okay? So now, we need to find the integral from 1 to 3, and we're going to add that from the integral from 3 to 5. Now, why would we do that? Well, because for all x that's less than 3, we're going to have one function. So which one of these integrals here have x values that are less than 3? Well, that would be this one. The interval from 1 to 3 is less than 3. So we're going to be using that integral for that one. So we're going to replace the f of x with 5 on this one. And then for the other one, where we're going from 3 to 5, if we're going from 3 to 5, that's where x is greater than 3. And so on that interval, f of x is going to be 2x minus 1. So basically, when you have a piecewise function, you have to integrate the pieces separately. You'll integrate this one and this one separately on different intervals. The first one goes from 1 to the breakup point, and then the second one goes from the breakup point to 5. Okay? Now from there, we're just going to evaluate the integrals like we always have. So we're not going to have too much fancy stuff going on after that, just some old school math. Okay, well, for this one, we actually have a property, don't we? I mean, we could just do our little property where it's property 6, where you have the height multiplied by the base. So for that first piece, we have 10. That's pretty nice and straightforward. The second piece, there's not a property for that. That's just we're going to have to integrate it old school style using the fundamental theorem of calculus. So I'll label what I did here. We did property 6, but for the next step, we're going to do the fundamental theorem of calculus, just because it's a regular looking function and we don't have any shortcuts for that. So we integrate this. So if I integrate 2x, I'm going to get x squared, and if I integrate minus 1, I get minus x. We're going to put a box on it, and we're going to put our limits here. Then after you do that, you're going to plug in your numbers. So I'm going to plug in 5 first. So that's going to be 5 squared minus 5. And then you're going to plug in 3 next. That's going to be 3 squared minus 3. And so I end up with 25 minus 5 minus 9 minus 3. That's 20. That's 6. Final answer there looks like 24 to me. And there you go. Now all this is review. This everything I have right here is review. But the process of taking this integral here and breaking it up into 2 separate integrals and then knowing that this one is 5 because I'm going from 1 to 3 and that this one is 2x minus 1 because I'm going from 3 to 5, that's the new part. So this is the part that's really important that you make sure you master today because that's new. The rest of it is old news. So let's do a little homework problem here. So this is homework problem number 1. So once again, on a separate piece of paper or wherever you're going to put your homework, go ahead and start this one. It's our first problem on the homework. So here we go. So the first thing I'm going to do is I want you guys to complete this statement here for me. You guys need to fill in 4 blanks. Pause the video here and give that a try. When you unpause it, I'll share you what the answer is. All right, so first of all, we're starting at -2. And then we're going to keep going until we get to 1. Because after that, we switch functions to a new function. The new function picks up at 1 and then finishes at the last point, which is 3. Okay? Now, the next thing I want you guys to do is I'm going to erase this. And I want you guys to put the correct piece in each spot. So what goes here and what goes there? Fill in those blanks. When you unpause the video, I'll share with you what the answer is. All right. So for the first integral that we have there, we're going from -2 to 1. And those numbers are less than 1, and therefore the first piece will be x plus 2. For the second piece, it will be the other one, 3x squared, because if we're going from 1 to 3, those are the values of x that are greater than 1. Okay? So that's the main thing I want to make sure that you guys get from our lesson today is that, setting it up. Because the rest of it is really all just review. All right? So what I want you guys to do now is I want you to pause the video and fill in these blanks here. Fill in those blanks. When you unpause it, I'll share with you what the answer is. So at this point, we're going to just do the fundamental theorem of calculus. So you add 1 to the power, which is 2, and then you divide by that number. And when you have just a number like this 2 here, you just put an x next to it. We're integrating. The other one here is x cubed. All right? From here, I'm going to say go ahead and pause the video and just finish up the rest of the problem on your own and see if you can actually get the correct answer in the end. And then you can compare your answer to mine. When you unpause the video, you'll see the final solution. All right, guys, so here's our answer. I'll let you study that, compare your work with mine. We end up with 30.5. Let's move on to a new question. All right, number 2. Let's talk about absolute value integration. It says only do setup, but I'm going to ignore that. We're going to actually just do the entire problem. So, well, we talked a little bit ago about how to deal with absolute values in calculus. We changed them into piecewise functions. So the first thing we want to do is change this into a piecewise function. Now it's been a while since we've done that, so let's refresh our memories on how to do that. You take the inside portion there, set it equal to 0, and you solve. And what that tells me is that for my piecewise function, my cusp, the place where the two pieces are going to meet, is at -3. So we're going to have one half of the function to the left of 3 and the other half to the right of -3. Now, what we're going to do is we're going to put that function in here twice, 2x plus 6 and 2x plus 6. And one of them is going to end up being an opposite sign. The way you could tell is with a number line test, where you put the cusp of your absolute value function in the middle. And what you're going to do is you're going to pick a test number on these intervals. And you're going to plug it into the absolute value function to see if a change happens or not. So let's plug in -4, that's to the left of 3. Let's see what that gives us. That's going to give me -8 plus 6, which is -2. And as you guys can see, the absolute value will change the sign. It's going to change it from being a -2 to a +2. So to the left of -3, in other words, for all values of x less than 3, we will change the sign. To the right of -3, we probably won't change the sign. It usually does the opposite. But we could check just to be sure. But let's see what happens to the right of 3. So let's pick a number bigger than -3, like 0. The absolute value of 6, well, the absolute value of 6 is 6. There was no change. So for that one, we won't put a negative in the front. So as you guys can see, based on the number line test, since this interval resulted in a change, for this interval in my piecewise function, I put a negative in front because it changes the sign. Okay? And there's our piecewise function. Now, it might be helpful to us if we go ahead and just distribute this negative into the parentheses. And then we'll be good to go. We don't really need the parentheses on this one at all. So there we go. And that's that. That's our piecewise function. So that's step 1. All right, and now we will move on to step 2, which is where basically we're going to do exactly what we did before. We want to find the integral of this absolute value function, but really all we're going to be doing is taking the integral of this piecewise function here. And so we're going to break it up into pieces. So step 2, break it up. So we're going from -5 up to our break-off point. And then we'll pick up at that break-off point, and we'll end at our upper point there. Okay? And on the interval from -5 to -3, that's less than -3, so that would be this piece. And the other one goes here. Now for these ones, I think we will skip the process of doing the actual working it out, but on your homework, I would like you guys to do that. But in the interest of time, I'm just going to say for step 3, you're going to work out the problem from here using the fundamental theorem of calculus, just like we did on the last problem. But I don't really want to spend the time doing that right now, just because that'll just take time up from making you guys write stuff in your notes and stuff. And you've already seen an example like that today, so we don't need to worry about it. But I am going to be saying that's what you guys need to do. So step 1 is to change it into a piecewise function. Step 2 is to break that up into 2 pieces. And step 3, which I'm not going to do, but you guys are going to do, work out the fundamental theorem of calculus and get your final answer. All right? So, your guys' turn. So go ahead and take your homework back out now, and you're going to do number 3. Do number 3. So pause the video here. Actually, you know what? we could do it in steps together, actually. So why don't we start like this? Why don't we say, go ahead and let's just write the piecewise function first. So pause the video here and see if you guys can accurately figure out the piecewise function representation. All right, there's our answer to number 1. Okay, now for the second step, I want you guys to go ahead and write the integral in 2 pieces. When you unpause the video, you will see what that should have looked like. All right, so that's what you guys should have had for step 2. Study that for a second. And then you guys are going to go ahead and do step 3. Even though I didn't do it on mine, I want you guys to do it, where you actually calculate the answer using the fundamental theorem of calculus. When you unpause the video, you will see the solution. All right, should have gotten 40, so I'll let you guys study that and see what you think. And we'll move on to the next one. All right, let's go ahead and take a look at another problem. So right here, I've got a quadratic equation, and this is its graph, going from -5 up to 0 along the x-axis. Now, I'm going to put some absolute value bars onto this quadratic equation. Now, what that's going to do is it's going to make all the outcomes positive. So this whole region down here, which used to be negative, is now going to get made positive. And so now it looks like that. So it just flips anything that was under the x-axis to being above. So that's what absolute value functions do. It takes anything that would be below the x-axis and flips it up. Okay. Now what I want to do is I want to find the integral of this function from -5 to 0. Now as you guys can tell here, we're going from, we have this piece right here from -5 to -4. And then we need to do another integral from -4 to -2. And then we're going to have to do another integration from -2 up to 0. And so we've got 3 different little areas that we need to add together. And therefore, we're going to have 3 separate integrals. Now, the trick here on this is, how the heck do you know where these cusps are? Well, it's actually the same thing we've been doing. Okay? But I just wanted to give you guys this visual representation before we actually began the process. Okay? So now once again, you won't really have this picture whenever you're doing your problems, but I wanted to share the picture with you just so you can kind of get a visual of what it is that we're doing. So the last the last absolute value function we had was not quadratic, so it only looked like a V shape. But this is quadratic, so it looked like that weird shape that I just showed you a second ago. So how do we do this? Well, you take the part that's inside the absolute value, you set it equal to 0, and you solve. Now the only thing that's different this time is that in order to solve it, you need to factor. Now I've noticed a lot of you guys prefer to use the quadratic formula because you're kind of insecure with your factoring. Man, I wish I can get you guys to know how to factor, because it's so much simpler and it could save you so much time, and there's just so much room for error on that quadratic formula. But hey, if you like it, then stick with it. But anyway, there you go. So I've got 2 cusps, which we saw in the picture earlier anyway, right? So that doesn't surprise us. And then we go ahead and we do our little number line test here. So we're going to have -4 on the left, -2 on the right. I'm going to go from smaller to larger, left to right. And what we're going to do is we're going to plug a number in from each interval to see whether there's a change or not. Okay, so I'm going to plug in -4. Oh, you know what? I don't want to plug in -4. I take that back. I need to plug in something smaller than -4. My bad. So let's plug in like -5. And then something between -4 and -2. Really, there's only one convenient number to use there. Unless you like fractions, which I don't. So I'm just picking a number from each interval and plugging them in. We'll see what we get. Now, as you can see here, this is just going to come out to be the absolute value of 8, which has no change associated with it. So for all x greater than -2, there will be no change. Okay? Now, usually what's going to happen then is that this piece will be the opposite. It will be a change, and this piece won't. It kind of flips back and forth. But just to be sure, let's go ahead and calculate it just to be sure. So this is 9 minus 18 is negative 9 plus 8 is negative 1. So just like I expected, this will result in a change. So anything where x is between negative 4 and negative 2, there will be a change. And then for all x less than negative 4, we could probably predict there won't be a change. Let's see. 25 take away 30 is negative 5. Plus 8 is positive 3. And when you take the absolute value of a positive, there is no change. So yes, once again, my little prediction held up. So there it is. Now, as you guys can see, there's 3 parts. And so whenever I go to write this as a piecewise function, it is going to be written in 3 pieces. Okay, so that's what happens with the quadratics. They do that. My first piece will be for all x values less than negative 4. And for that one, there's no change. So it's just going to stay exactly the same as we see it there. For all x between negative 4 and negative 2, there will be a change. So it's going to change all these signs. And then finally, for all x greater than negative 2, there's no change once again. So there, we've gotten step 1 done. We've successfully changed it into an absolute value, or we've changed it into a piecewise function, I should say. And now we're ready for step 2. Step 2 shall be done by, once again, just writing some integrals out, right? So this integral is going to be rewritten now as 3 separate integrals, 1 integral for each piece. 1, 2, 3. Now for the first one, we're starting at negative 5, right? And we're going to keep going until we get to negative 4. And then the next one starts off where that one left off, and it keeps going until it gets to negative 2. And then the next one picks up where that one leaves off and keeps going until we get to the very end, which is 0. Right? And so for the first integral, we said it was no change. For the second integral, we said, okay, that one has a change. And then for the last one, we would do that. And that's step 2. So step 1, write out your piecewise function. Step 2, write it as 3 separate integrals because we have 3 separate pieces. And then step 3, once again, is that old fundamental theorem of calculus. This one's going to have 3 brackets that we're going to have to be combining together. So that one's got a lot. But once again, in the interest of not filling up your paper with excessive amounts of writing, I'm going to not do that because we've done that enough. I'm going to let you guys do it on your homework, though. So let's go ahead and transition into your homework problem here. So go to your homework, look at problem number 5, and you're going to be doing this problem here. So the first thing I want you guys to do is I want you guys to write it as a piecewise function. So go ahead and pause the video here, and when you're done, unpause it and see if you'll get it right. Now, before you guys get started, though, this little negative, be careful with that guy. He's not inside the brackets there. So, you know, it's like, think of it like a -1. So that thing's separate from the rest of that absolute value. So keep that in mind as you're going through the process. All right, so I've got my work showing off over here on the right side. Set the inside only equal to 0 and solve. Do your number line test, and you can see which parts are changing. Now, this part is where that little negative I was telling you about comes in. It's a little bit strange. I put it in red here. That piece is not going to change. It's going to stay exactly where it is the whole time. It has nothing to do with the absolute value process. Okay, so the middle one that's changing here between -3 and 0, that means it's going to, the part inside the parentheses is going to change. But the negative on the outside is not affected by this whole absolute value process. Now, a better way to write this is instead of having the negative on the outside, would be to go ahead and distribute it in for each one. Okay, so I'm going to go ahead and do that now. So if I distribute the negative in here, both of these become negative. And if I distribute it in here, they both become positive. And then the last one, they both become negative once again, like the top one. All right, so that's step one. All right, now step two, I want you guys to pause the video and see if you guys can write out the integrals. So go ahead and pause the video and see if you guys can write out the 3 integrals that will make up this piecewise function. All right, there you go. So that's what it should have looked like. I want to make sure you had 3 of those, of course. You should be paying attention to the limits that I have here. Your limits should be the same. And for the first piece, that's the one where we're both negative from the top. It's the middle one, and that's the bottom one. Okay, so make sure those components all match. All right, now I do want you guys to go ahead and practice the fundamental theorem of calculus here. So let's go ahead and do step 3. Pause the video. Do as much as you can, and when you unpause it, you'll see my solution. So I stopped here because I ran out of board space. This is pretty wild, isn't it? Matter of fact, I've done it twice now. I got it wrong the first time. There's lots of places to go wrong. The negatives got me. So you got to be careful with those. But this is correct now. So if you need to take a minute to check your work up to this point, this is what you should have. Now, beyond this, I'm going to show you how I would handle it at this point because fractions are no fun, and it would be nice to have a way to kind of have to avoid having to deal with those as much as possible. And so that's what I'm going to do with you now. Is I'm going to show you how I would put all this together. Basically, I'm going to put everything together that's easy to put together first, and I save the bad stuff for last. And that'll actually help reduce some errors. So if you just do the easy stuff first and the bad stuff last. So let me show you what I mean by that. So I have some whole numbers here. I've got 9, 24, 9. The zeros don't really matter. So if I add together those numbers there, 9, 9, and 24. That's 18 plus 24. What would that be? That would be 34 plus 8 would be 42, I think. So adding those 3 numbers together, I get 42. Next, I'm going to combine everything that has a denominator of 2. Just add the numerators. So negative 27, and negative 3 makes negative 57. So it's going to be negative 57 over 2. And then we're going to combine everything that has a denominator of 3 now. So negative 64 and negative 1, that's going to be negative 65 over 3. So now we've got all of our terms. We've got 3 simplified fractions. That's going to make it a little bit easier than trying to get them all to have a common denominator first. So combine the ones that are already the same, and then we can worry about common denominators. Now, do you have to really do all this? Well, I mean, I don't mind if you just do the calculator and get decimals either, honestly. It's up to you, but it could happen to where you'll have a multiple choice test and you're going to need to know how to do this. It is tedious though. All right, so I'm getting a common denominator of 6 all the way across. So that's going to be 240 plus 12 is 252. The next one is going to be 150 plus 21 is 171. And then 65 times 2 is 120 plus 10 130. And then we're going to combine all of our numerators together. So we have 252 minus 171 minus 130, and I'm getting negative 49 over 6. And that's probably good enough. We can stop right there. Okay. As a decimal, if you guys decided to go the decimal route, you'd see something like negative 8.16 bar. That'll be it. That's a lot of work to do, I feel you. So that's going to help you appreciate the next part of our lesson here a whole lot. Okay? Still want you guys to do these things by hand, but I do want to show you something kind of cool that I want to encourage you to use anytime that you can, because it'll save you a lot of time. This problem that we probably just spent about 10 or 15 minutes on, you could have this done in about 2 minutes using a calculator. And I'm going to show you how to do that right now. Okay, so get your calculators out. Make sure you guys practice this with me here. Now, on your homework, I want you guys to do all of this stuff by hand, but you can definitely practice doing it on the calculator. I might allow you to use a calculator, like on the test, for instance. I'm not going to be able to necessarily say don't use your calculator, but you know, so it's nice to know how to do it. It could save you some time, so it's a good thing to do. But let's go ahead and get down to business here. So first of all, we want to put our function in, of course. So let's go ahead and push y equals, and we want to type in our function. Now, the function that we were doing on the last page was negative and then absolute value. How do we get absolute value? You're going to push this button here that says math, and then you're going to scroll over to where it says NUM, and then the very first option there says ABS with parentheses, so we're going to click 1, and that puts absolute value bars on our things. And then inside the absolute value bars, we're going to type the function that they gave us, which was x squared plus 3x. So there's my function. So now I've got it stored into my calculator. So let's go ahead and get out of here. Second quit. That takes you to the home screen. Now we're going to do the integration. So we're going to push math. And we're going to scroll down until we get to number 9, which says FNINT. That means integral. You could just push 9 instead of scrolling there. And then we're going to enter everything that we were told to enter. I believe our integral went from -4 up to 1, if I'm not mistaken, right? And then what goes here is the function that we want to put in. Now, honestly, we didn't have to put the function under y equals. We could have just typed it right here. But I really want to encourage you guys to keep doing it that way, because that will come in handy for many other kinds of future lessons, especially in Unit 7. So I always teach it that way. But anyway, so instead of retyping it, we can just go to vars. We could scroll over to y vars, push 1 for function, and then push 1 for y1, and that puts it in there, and then x for dx. And then you should be able to put enter. Now, these things are absolute value functions, take up a lot of memory on the calculator, so it takes it a long time to load the answer. Don't be surprised. But there's the answer, -8.16 bar. You could even change it into a fraction if you want to. You could push math, and then 1 for fraction, and then enter. Oh, it didn't do it. Should have done it. Try that. No, it won't work. Oh well. Surprised it didn't do that. Anyway, guess I won't mess with that today. It's not a big deal. So, feel free to do that. Feel free to use your calculator. Much faster than working it out by hand. So anytime you can, do that. However, for your homework, I really want to encourage you guys to do all of them by hand. So show your work. But I would practice the calculator on all of them just to kind of make sure you're knowing how to do it on the calculator, because it may come in handy where there's going to be a time whenever you don't need to show your work. And if you can just punch it in the calculator, you can totally get the right answer. All right, so that's where we'll stop for today. Hope that was helpful, and I wish you guys a good rest of your day.